Okay, so welcome to part 2 of the high frequency questions predicted for IGCSE. Okay, so question 11. So Jessica runs for 15 minutes at an average speed of 6 miles an hour. She then runs for 14 minutes at an average speed of 9 miles an hour. If Amy takes 45 minutes to run the same total distance, work out Amy's average speed. Okay, so first of all, what do we know? Speed equals distance over time. We're currently in hours, so I'm going to change 15 minutes and 40 minutes into hours. How do we change into hours? We divide by 60. Okay, so 15 over 60 is a quarter, okay, or 0.25. Now, 40 over 60 is 2/3 or 0.3 recurrent. However, I don't know how to put 0.3 recurrent into my calculator, so I'm going to keep it as a fraction. And this is where most people go wrong, by the way, so it's really important we know that. So now we have our minutes into hours. So we know speed equals distance over time. We're trying to figure out the distance. So distance equals, if we bring that up, speed times time. Okay, so first of all, our distance is going to be our speed, which is 6 miles an hour, times our time, 0.25. So our first distance is 1.5. Then our second distance, she does 9 miles per hour for 40 minutes. I'm going to multiply that by 2 over 3. It's going to give me 6. So that means her total distance is 6 plus 1.5, which is 7.5 kilometres. Now, just a side note, if you'd have kept this as 0.3 recurring, you wouldn't have got a nice value here. Okay, so we can see that the total distance is 7.5. So now, what do we know? Amy takes 45 minutes, and remember we want miles per hour. Okay, well, 45 minutes. If I'm changing this into hours, I divide it by 60. Okay, and what do I get? 3 over 4 or 0.75 exactly, which is quite nice. So for Amy, we know we want to work out her speed. Speed equals distance. It's the same distance as Jessica, which we've just figured out. 7.5 divided by time. Now, you can write 3/4 or 0.75. If you do write 3/4, make sure you put 3 over 4 into your calculator, or it won't work it out properly. So 7.5 divided by 0.5, and then this is going to give me 10 miles per hour. Okay, it's a 4-mark question. Okay, question 12, standard form. So, first of all, ordinary number, -3, so we know it's a decimal, so 1, 2, 3. So 0.00163. Nice and simple. Then, standard form, remember we need a number between 1 and 9, so 4.38. Okay. If I put the decimal point here, it came from here originally, so it's 1, 2, 3, 4, 5. Times 10 to the power of 5. And again, double check it to your calculator. You will get that right answer. Now, you can work this out, give your answers in a standard form. So you can actually put this straight into your calculator, right? And when you put this into your calculator, 4 times 10 to the power of 3 times, oh my. So if I put this into my calculator exactly how it is, 6 times 10 to the -6. Oh, it's giving me a syntax error. Wait there. Okay, so you can literally just type it in. It's going to give you 0.24, and then you can move the decimal. So this is going to give you 2.4 times 10 to the -1. Okay. However, sometimes they're going to give you that big numbers that it doesn't do that. They want you to understand what's going on here. So let's actually break it down. Let's see what's going on. We're multiplying, right? So what do we know with multiplication? We can switch it up. For example, we can say this is the same as 4 times 6 times 10 to the 3 times 10 to the -5. 4 times 6, 24. Okay? I don't know why I just put 25, sorry. 24 times, and then remember, if the bases are the same, we can add the power. This becomes 10 to the minus 2. But this is not in standard form, and remember, in standard form it needs to be a number between 1 and 9. So if I am dividing it by 10, I need to now change this to minus 1. Okay, so those of you looking to get those higher grades, make sure you understand how to do this. Okay, question 13. This comes up every year. Cumulative frequency. There hasn't been a year where one of these hasn't come up. They come in different forms though. Sometimes, they have the graph. They ask you to find this. Sometimes there's all sorts of different ways. So step 1, you need to understand how to do it, then problem solve with it. So you can see here, this says between 0 and 50, there was 10. Okay, so between 0 and 50, there was 10. But between 50 and 100, there was 15. I want between 0 and 100. Between 0 and 100 is both of these. 10 plus 15, which is 25. Between 0 and 150 is all 3 of these. So this is why it's cumulative, because we keep adding. Okay, 50. Then we're going to include the 30 because we go up to 200 now. Okay, and what do we get? 80. Then 85. Then 100. And you're right. If 100, your total matches your total, this is how it should be drawn. Now, for the frequency table, we are going to plot the last number in our interval against our frequency. So 50, and then up 10. Okay, 100 to 25, then 150 to 50, 200 to 80, 250 to 85, 300 to 100. Okay, so then I'm just going to use so here we go. It's going to look a bit like this. You can start at 0 if you want. Make sure you go through all the points. Beautiful. Okay, now we've drawn our graph. It says use a graph to find an estimate for the number of days in which the profit was less than £125. Okay, where is £125? £125 is here. So you can go up on your graph. I'm going to stop there. We're going to go across. And we can see that this is 32.4. This is 34. If you draw these lines as well, if you make a slight mistake, you will get method marks. So we can see here we've got 34. And then it says use your graph to find an estimate for the interquartile range. So this time we're drawing on the other side. What is a median between 100 and 0 is 50. So we know this is our median. So 75 is our upper quartile, which we're going to go across and down. So what's this? Roughly, oh my god, this is 175, so these must go up in 175, 180, 185, okay? Lower quartile would be at 25. We go across at 25, and we get 100. So 185 is our upper quartile, minus our lower quartile, we're going to have 185 minus 100 is £85. Okay? And then, depending on your graph, as long as you show you're working, this is perfect. Okay, question 14. We have probability. So, here is the frequency and the score, and she's now going to spin another 2 times. Work out an estimate for the probability that she gets a score of 5 both times. First of all, what is the probability of getting a 5? The probability is 10 out of this total frequency, okay, which is 10 out of 40, 1 over 4. So the probability of getting 5 both times is the probability of getting a 5 and the probability of getting a 5, which is a quarter times a quarter, which is 1 over 16. Okay, now if you did use decimals and you put 1 over 0, you put 0.0, oh my god, 0.0625, that will also be accepted. But if you rounded that, you won't get the full marks. It says Derek is going to spin the spinner a large number of times. So we don't know how many times. Work out an estimate for the percentage of times Derek can expect to get a score of 1. Okay, so what's the probability of Derek getting 1? This is 6 out of 40. Now, 6 divided by 40 is 0.15. If I want percentage is out of 100. So if I multiply that by 100, I get 15%. Normally here, though, they don't say a large number of times. Normally they say 300 times or 200 times. So you'd find your probability and times it by that actual number, but they've been a bit sneaky, so multiply it by 100. Okay, Venn diagrams and sets. So they put these in every year, sometimes slightly differently, but understanding how to draw this is really good. So first of all, read the question. Search for the one that says 4 uses all 3 types. Search for the one that says uses all 3, because that's going to give us our starting point. Okay, and then we're going to highlight them. 60 do not use any. Right, so that means 16 goes on the outside. 8 use both type A and B, but not type C. So 8 is here technically, A and B, but then when it says not C, actually, it just means this. So you know that this is 8, okay? Then it says 14 use both type B and C. So B and C is here. And this is 14. But we already have 4. So what plus 4 is 14? 10. Then the next two. 62 in total use type A. Okay, so I'm going to write 62 here. Then it says all 20 who use type C use at least one of type A and type B. So that means all 20 that use type C. So that means have A or B. So all of C use A or B. So there shouldn't be any C on their own. So 4 plus 10 plus what is 20? This is 6. Okay. Then we know that all of A needs to be 62. So 6 plus 4 plus A is 18 plus what is 62? That's 44. And then what do all of them have to add to? 100. So I'm going to add all these up. So 0, 16, 10, 4, 6, 44 and 8. And that gives me a total of 88. So that's 12 left over to add up to 100. Okay, so you've got to make sure, this is like solving a game. If you ever played Sudoku, that's literally what you do. Now, it then says one of the customers is chosen at random. Given that this customer is a type A, that means I can only choose from A. I can only choose from A. Okay? So if I can only choose from A, my denominator is only out of 62. Because I can only choose from A. And A is all of A is 62. And then it says, find the probability that also uses type B. Type B is just that 8 and 4. So this becomes 12 out of 62. Some of you might simplify this to 6 out of 31. That's also okay. Okay, products of prime factors. I haven't seen an easy one like this in a while, but you never know. It might happen. Let's understand. 500. So many people do this different ways, okay? I like to write down the prime numbers. 2, 3, oh, I've missed one. 5, 7. I don't mind which way you do this as long as you do this correct, okay? 11. So what is 500? I know that that's 50 times 10. Okay, what is 50? 5 times 10. What is 10? 5 times 2, 5 times 2. And I stop when all my numbers are prime. And then I get 2 squared times 5 cubed. Now, what you can do is on the calculator, you can double check this. You still have to show your working to get all the marks, but it's nice to double check. So literally what I did was I entered 500, I pressed equals, and then I pressed shift, and then fact. This fact button means factorials, okay? Does it mean factorials? Sorry, factors. But it does it in terms of prime factors, which is what we got, 2 squared times 5 cubed. Okay, so indices and fractions. This is, this is nice, isn't it? Okay, so you must show all your working. So you might be able to put this all in the calculator to get the value. And let's put it in to see what we should be getting. Okay, so I put this into the calculator. It tells us our answer is 16, so at least we know what we're working towards. Make sure when you're using mixed fractions in your calculator, you press shift and then the fraction button. You can see here this is going to give us a mixed fraction button, because if you just put 5 and 4 over 9, it multiplies them. So, and if it ever gives you it like this in brackets, always use brackets. Sometimes your calculator is not as smart as you think it is. Okay, but let's actually show this, okay? Let's actually show this. So first of all, this will help you as well with algebra. I suggest turning everything into a mixed fraction first. So what do we know? 5 and 4 ninths. 5 times 9 is what? What is 5 times 9? 45 plus 4. So I get 49 over 9 times, and then 4 times 3 is 12. I get 14 over 3. Okay, I'm going to worry about the denominator in a minute. This is to the negative a half. What does negative mean when I do that, the fractional negative indice? It means I flip my fraction, okay, because I want the reciprocal of it. So this is 9 over 49 to the positive a half times 14 over 3. So now what do I do? What does half mean? It means square root. What's the square root of 9? The square root of 9 is 3. What's the square root of 49? 7. So now I get this times 14 over 3. Now, I like to use cross multiplication for this. 3 and 3 is 1 and 1. 14 and 7. How many 7s in 7? 1. How many 7s in 14? 2. The actual answer is 2. Okay? I can't believe it, but it is just 2. So now I have 2 over 2 to the negative 3. What do we do when we divide with indices and the base are the same? This is saying 2. This is the same as 2 divided by 2 to the minus 3. When we divide, we take away the powers. 2 on its own is 2 to the power of 1. So I'm basically saying 2 to the 1 minus 3, which is 2 to the power of 4. What is 2 to the power of 4? That is 16. Now, again, there are definitely lots of different ways you could have attempted to solve this question. Okay, this is just one way. And, oh, sorry, guys, 2 to the power of 4 is 16. And you can see we got 16, but we've shown how we've got 16. It's really important we understand how to show. Okay, I love these questions. Upper and lower bounds, they come up every year. Okay, so first of all, what I always suggest doing, because you get a mark for this, is write in the upper and lower bound of each one. Okay, 1 decimal place. What's the upper bound then? If you're not sure, 6.8, if it's been rounded to 1 decimal place, that means 6.9 or 6.7. So our lower bound and upper bound is in between here. What's in between 6.8 and 6.9? If you don't know, put them into your calculator, add them together and divide them by 2. However, it is 6.85. Lower bound, 6.75. Okay, that's in the middle. If you don't know how to find the middle, you can put them in your calculator, add them, and divide them by 2. Essentially, we're finding the median. And then the same, I'm going to change the colour for this one, to one significant figure. Well, what is one significant figure up? This is to one significant figure. In this case, one significant figure is the nearest hundredth, so we can go nearest hundredth up, nearest hundredth below, and then we're going to have 0. Upper bound 0.055, 0.045. Again, if you don't know, please you need to find the middle. Okay, so that's a mark at least for one of those. Then we need to figure out what we need. It wants us to find the biggest number of P. So I want the biggest number P could possibly be, and I'm square rooting it. So whatever I'm square rooting, I want the square root to be the biggest number I can possibly have. Okay, because that would give me the biggest value of P. You know, like the square root of 16 is 4. But the square root of 4 is 2. So the bigger the number inside the square root, the bigger the answer. Okay. But what's inside the square root? I have a fraction. So this fraction needs to be the biggest fraction it can possibly be. Now imagine this. A biggest fraction means I want top heavy. Okay, or I want the bigger number as the numerator. Do you think 10 over 4, well, that's bigger than 4 over 10, isn't it? Okay, so I want the biggest number it can possibly be on my numerator. So I want my numerator to be my biggest divided by my smallest. Okay, so I'm going to get P equals the square root of the biggest numerator, which would be using my uppers of E, divided by my smallest denominator, which would be using my lowers of F. So it's going to look like this. P equals the square root of 2 lots of upper E's, 6.85, over my lower F, 0.045. And this is going to give me 17.483, etc. However, it says 3 significant figures, so that's 17.4.